the very first thing to understand with binary search is that we're making a huge assumption in that the array we're putting in is already sorted. So in this case, I've got a sorted array of the integers from 0 to 9, ascending order. And so that is the very key thing to make note of before you implement your binary search algorithm, is to know that you're making that assumption. With that out of the way, the very first step in actually doing binary search is to initialize your left and right bounds. And so in this case, I will make the left and right bounds set to the first and last elements of my array respectively. And then what we're going to be doing is calculating the midpoint. To calculate the midpoint, you basically just take the average of these two values and we truncate the decimal. So in this case, I'm going to be finding the average of 0 and 9 for the index. And so the average of 0 and 9 is 4.5. But because we just truncate the decimal, this means that we'll look at position 4. So we'll set our midpoint value to position 4. And then we're going to check the midpoint index and look at the value. So that's the midpoint value. And in this case, 4 is 4 equal to our target. Our target is the number 7 in this particular example. And because the number 4 is smaller than the target, what we were going to do is increment the index of our left bound by 1. So basically we're going to put this guy, we're now going to make the left bound 5. And next what we're going to be doing is recalculating the midpoint index. So we're going to take 5 plus 9, which is equal to 14. And then what's going to happen next is you're going to divide that by 2. So 14 over 2 is 7. So now we will set our midpoint value to 7. And what will happen now is we'll check if the midpoint value is equal to our target. It is. Therefore, we're going to return this midpoint index because we will know that is where the position 7 is in our array above. And so this is the logic behind it. And we'll also have a condition where if you ever get to a point, like if I asked you for the number 10, what will happen in that case, so let's just walk through another little logical example. If we were looking for the number 10, our target was 10, we're going to calculate our midpoint. And our midpoint here is going to be 4 as it was before. And is 4 smaller than or greater than 10? It's greater than, it's smaller than 10, so we're going to move our left pointer. We're going to, again, run this operation where we're going to say, what's the average of 5 and 9? That's going to be 7, so we're going to move our midpoint again to 7. And then is 7 less than or greater than 10? In this case, because 7 is smaller than 10, we're going to move our left pointer to the left of it. And now we're going to calculate the average of 8 and 9. So 8 plus 9 is equal to 17. And then the average of 17 is going to be 8.5. So we're going to set our midpoint to 8. And then is 8 smaller than or equal to our value of our target of 10, and because it is smaller than the target of 10, we're going to increment our left bound. And then what's going to happen here is we're going to see that both our left and right bounds are the same. And so in this case, what that means is that we're going to need to leave our loop and return -1, because that means that the element was not in our array. So that is the logic here behind it. And now if we're actually going to implement this in Python, I have the following terminal right here where we can look at this stuff. So as we were doing earlier, I'll say left, or I'll just call it L index, gets 0, and then I'll have the right index gets the following, which will be the length of our target array, or our array. And we're going to have to subtract 1 because that is the, we're 0 indexed. And next, what we're going to be doing is entering this while loop. So while, and while L index is less than or equal to R index, we're going to say the following. So we're going to calculate the midpoint index. So in Python, we'll say midpoint index gets L index plus R index. And we're dividing this thing by 2. This is a special operand in Python. It basically means take the division and discount the remainder. So we're just looking at the integer value itself. And now check the midpoint value. Midpoint value gets array midpoint index. And if midpoint value is smaller than, or well, let's just do the positive case. If midpoint index is equal to your target, then we will return the midpoint index. Else if the midpoint value is less than the target, we're going to want to increment our left index. So L index plus equals 1, and then else, and this is the case where our midpoint value is greater than our target, I'll say R index minus equals 1 to decrement the right bound in our loop. And now what we're going to be doing is, if we're able to iterate through entirely in this while loop, if it's never found, we're going to return -1. So if we make it through the while loop, then the element is not in array, return -1. And so that is how we're going to do this. And now we can start testing our code as follows. So in this case, I want to see if we're able to find where the number 7 is, which position is the number 7 in this thing. So I'm going to do a print command. So the target was at position blank in array, format, target, and binary search, target, and now we will run our code in debug mode. And we are getting an error message here. The list is not callable. And so there you go. So I accidentally used parentheses instead of square brackets, but we've solved that problem. So we're able to find where the number 7 is in the array. That's fantastic. Now I want to test this with looking at, see if we can find 0. It's able to do that successfully. And we're able to find the other extreme, which is 9. That's fantastic. And then if we try to find the number 10, we should get -1. And we're getting an error. List index is out of range. Except index error, turn -1, just so we handle all of our edge cases. And there you go. So that is how you can code up binary search in Python. And thank you all for watching. Hope this video helps, and I'll talk to you all next time.